Hi everyone, I welcome you all in today's session. And from today onwards, we are going to start our series on Pyspark and Databricks. And here I will be covering Spark and Databricks both. So, we are going to start from basics and going to the advanced level up till what the latest is going on in Databricks and in Spark side. So, before I set the tone of the session, we will go through some basic concept how the things evolve. It will be very helpful to understand that how the Spark came into the picture. Okay, I hope you like the session. And yeah, let's get started. So first and foremost, before I start about this, and this will be the complete playlist from basic to advanced, so just follow this playlist. I will be covering for every conceptual thing and coding thing. Each and everything will be covered in this playlist. Okay, in a very depth. Okay, so first let's see what is big data. Before we jump directly to the Spark, first let us understand what is big data. So big data in a layman terms is basically refers to when you are dealing with huge amount of data. Now what is mean by huge amount of data? When your data size is in TBs or in GBs in huge amount, that typically we called as a big data. Now here it is mentioning big data refers to extremely large and complex data set that cannot be easily managed. Okay, now if you go in a previous in history, there was nothing was there the concept of big data. It came into pictures when your variety of data evolves. Basically, variety of data, I mean to say, when your data is just not come in the form of rows and columns or table format. Typically your data comes in the form of rows and columns, right, in a table format. Now after a certain period of time, your data is coming in the form of audio format, then data is coming in your video format, then your data is coming in image format. As you see right now, the so many apps are coming, so many streaming apps are there. Okay, apps look like you can say Geo or Hotstar. They are floating data in the form of you can say all digital, all OTT content. They are floating data in the form of video, right? And also you can say the image format. So basically data is coming in so many different form, and in every second, or you can say every millisecond or every nanosecond, huge quantity of data is generating day by day, right? As you can see that you take an example of IPL. Okay, in IPL, whenever any live match is going on, so many people are, so many viewers are watching that it. Okay, so it continuously generating, and they are doing activity also, whether play, pause, commenting, liking, sending emojis. Okay, so there are also so many types of data in a variety of format are generating. So typically it's become very difficult for our traditional system, for our traditional data processing tool to handle such type of data. Okay, earlier there was spreadsheet, or you can say Excel, to handle it, but the volume has increased, the variety of data has increased. It become very difficult because Excel, spreadsheet, these are the ways to handle only the structure type of data, I would say. Okay, structure type of data which contains rows and columns. Okay, so here basically there are three categorization of data on the basis of type of data, variety of data. So structured data is there, unstructured data, and semi-structured data. Now when I talk about structured data, as we discussed, all your relational database, MySQL, Oracle, SQL Server, PostgreSQL, these are comes under structured data. Means data which is in the form of rows and columns, in the form of tables. It's called basically unstructured data. Now when I talk about unstructured data, so data which is coming in audio, video format, you can say like Spotify. Okay, it's a form of unstructured data. It's because you are getting data in the form of audio. Okay, streaming platform looks like Geo, you can take their data, or Hotstar you can take. Okay, here data is coming in the form of video format, right? So these categorization of unstructured data. Semi-structured data means data which comes under a JSON or XML format. Now I will let you know when we're going to study about these format, especially the JSON part, because it's very important from a Spark point of view. And typically in interview, there is certain questions which has been asked related to JSON only, means how you handle JSON type of data. So basically for right now, if you want to, you can Google it, or I will let you know, I will teach you in an upcoming video. So JSON is basically, you can say it's a key value pair. Here data is in the form of key value pair. Okay, so it's in the form of so it's basically an unstructured, semi-structured type of data. Okay, so that's mean, I think that is clear. Let's move on. So basically how, so there are typically 5 V's has been defined, okay, to categorize any data as a big data. Okay, that 5 V's is very important. So first one is your velocity. Velocity is means the speed at which your data is flowing or data is generating. Okay, how fast it is generating. So that is if your data speed is very huge, then that is considered as a big data, means how faster your data is generating. As I told you, we can take an example of streaming platform. Here the data is flowing in the form of video content, right? And if it is live, then your live basis your data is generating, right? So first one is the velocity part. Another one is the volume. Volume is the amount of data, means it's in how many GBs, or you can say how many TBs your data is generating, okay, to be qualified as a big data. There is typically not any standard benchmark to define that quantifying that volume, means what sort of volume it is. Value, third point is value. So value is basically what value that data provide, okay, means what information we can extract from that data. Variety, you can say, it means diversity in your data. Diversity in the sense, sometimes data come in the mix of audio, video, then some text format, each and everything, right? So that is, you can say, diversity, means what type of variety. And then come your veracity, is means data quality, and accuracy, means how accurate your data is, what is the quality of your data, right? So these are basically a 5 V's of your data, means your velocity, volume, value, variety, and veracity. Okay, now before we jumped into more on the big data side, I want to discuss here one important term, that is called scalability. It plays a very important role in big data world. Now what do you mean by scalability? So in a layman term, scalability means is your ability to grow, okay, depending upon the traffic or depending upon the load which you are getting from your server, or from any other sources, from your viewers are increasing. So it is a system ability to grow. Now how you are going to grow? So we define it scale down, scale up, or scale out accordingly. So we are going to discuss about these things. So basically under this scalability, there are 2 types of scaling is there. There are 2 major category of scaling. So one is the horizontal scaling, and another one is the vertical scaling. Okay, another one is the vertical scaling. Now if you are running any website or web service or any application, its success depends upon the amount of network traffic it can handle. Okay, suppose you can take a use case. Suppose you are watching an IPL match on Geo, right, on Geo Cinema, and you're watching a live match. Now suddenly you say there are 1 lakh subscriber or 1 lakh viewer is watching. Now it is jumped to 5 lakh, then it is jumped to 10 lakh, and you are still going to watch it without any buffering, without any lag, without any app is not getting crashed. Then you can say that Geo has built a very robust platform. Okay, just for example I am taking, and so they have a very good scalability. The system have a very good scalability, it can handle such amount of traffic. Okay, so that is the one part. So you can take, so scalability describe your system ability to adapt to change and demand. Okay, suppose your viewers are increasing, suppose your viewers are decreasing. So depending upon your number of, means the depending upon the quantity of traffic or the number of viewers, your system is scaling up and scaling down. So that feature is basically called the scalability. Okay, good scalability protect you from the future downtime and ensure the quality of your service. If your system is very highly scalable, then you can deliver your service in a much better and faster way. Okay, now here the term we are using downtime means suppose you are watching an IPL match and suddenly the traffic increases. Suppose it was IPL final and suddenly it increases to CR, the viewers count, okay, the audience count, and suddenly the app crashed. Or downtime means the time where your system is not active basically. Okay, and suddenly your app got crashed, then you can say that in terms of scalability is not that much robust. Okay, but if you still going to watch the video with the same picture quality without any buffering, or then you can say without any lag, then you can say the system is highly scalable. Okay, so that is the one thing I want to discuss with you. So keep this in mind, what do you mean by scalability. Now coming back to horizontal and vertical scaling. So yeah, let's first study about horizontal scaling. So what is horizontal scaling? So horizontal scaling is nothing but, suppose you have one resource. Okay, you can take any compute resource, you can take it as a server or anything, and suppose suddenly your load is getting increases in your system. So what we are doing, we are putting one more resource, then we are putting again resource, then we can put another resource. So this type of addition of resource is basically called the horizontal scaling. Means we are increasing our resources horizontally. So horizontal scaling is means scaling out refers to adding additional node or machines to your infrastructure. So suppose initially there was one machine, then you add another machine, then you add another machine, then you add another machine, depending upon the traffic, depending upon the demand side, means how much demand is required to cope with new demand. If you are hosting an application on a server and find out that it has no longer has the capacity or capability to handle traffic, then adding server may be your solution. Hope that's clear to you. That is basically means by horizontal scaling, and in big data world this type of scaling is more preferable. Even you, I want to tell you that Spark works on horizontal scaling only, because in Spark we will see in detail in the coming lectures. Basically what we are doing, we are creating clusters. Okay, we are creating clusters in Spark. So what are clusters? Clusters is basically, you can say, a group of computers, a group of machines to compute faster. Okay, and the machines are works on that horizontal scaling phenomena. So you can say, this is one screenshot I have taken to get a better understanding. Suppose initially there was one server. Okay, this is a server configuration, 1 CPU, 8 GB RAM, 1 TB SSD. Then suddenly the load is increasing on your server, so it become very challenging to handle that load with just one server. So we are adding it horizontally. Okay, so this is come pool of server, so your resources will be distributed equally. Okay, so this is, we have increases the capacity, right? So this is basically called as horizontal scaling. Now let's move forward. Now let's see what is vertical scaling. So vertical scaling is you say, just suppose this is the one machine you are having. Now we are piling up on top of it. Okay, so this is basically called vertical scaling. So vertical scaling is also known as scaling up, describe adding resources to a system so that it meets demand. Now how it is different from horizontal scaling? Okay, means how can you say, means which one is better? So while horizontal scaling refers to adding additional resources, vertical scaling describe adding more power to your current machine. So basically here not we are adding machines, we are not adding servers here. Okay, so what we are doing, we have only one machine, but we are just increasing its power. Suppose you can say you have one machine. Okay, you have one machine, and suddenly the traffic is increasing, and we come to know that with just that machine with the same set of configuration we are not able to handle that much amount of traffic. So we are it's increasing its power. So we are here not we are giving multiple machines to it. For instance, if your server require more processing power, vertical scaling would mean upgrading the CPU. Suppose you have 3 CPU core, you are increasing it to 10 CPU core, means upgrading the CPUs. You can also vertically scale the memory, storage or network, but for big data point of view it's not recommended this type of scaling, because in this type of scaling basically it's not an efficient way, because ultimately entire load lies on this just one machine, and suppose some glitch happen in this one machine, so it will be very difficult to handle it, because it will be a lot of time taking, there will be a lot of downtime involved in it. Okay, because you have to debug, means what is the error, then you rectify it, then you will start the machine. So this one is not preferable. In spite of that, in horizontal scaling there are multiple machines. So suppose if your corresponding one task is not working, now we can check it that this task is run by which machine. Okay, so there are also certain features we will study in this detail. So these are basically two type of scaling: horizontal scaling and vertical scaling. So yeah, so you can check here, this is typically a vertical scaling. So basically you are increasing the power on just one machine, not a multiple machines is there. Okay, so initially there are one CPU, then you are a dual core CPU, quad core CPU, 8 GB RAM, 16 GB RAM, 32 GB RAM. Okay, so this is called vertical scaling. So you can check here, this is I think will be much clearer to you what is horizontal and what is vertical scaling. So this one is basically your vertical scaling, this one is your horizontal scaling. Okay, so yeah, means I hope you like the session, and this is basically the start we have started. So I try to brief you about the few basic terminologies of big data and terms and concepts, so that whenever we are going to learn more advanced, so it will be more clearer to you. I hope you like the session, and thanks for having me, and thanks for watching. Thank you.